Let's write, okay, the hypothesis I believe already mentioned. Null hypothesis, mu equals 375, alternative hypothesis, mu not equal to 375. Okay, against the alternative hypothesis, mu not equal to 375. Okay, 5% significance level, random sample of 16 boxes, the sample size is 16. So they have basically taken boxes of dried beans that have contents whose masses are normally distributed with mean mu and standard deviation. So we have the standard deviation of the population as well. Standard deviation of the population is 15. So for what values of the sample mean is the alternative hypothesis accepted? Accepting an alternative hypothesis means you are rejecting the null hypothesis, right? So for what value of the sample mean are you going to reject the null hypothesis? In other words, they're asking you to define the rejection region. To identify the rejection region. That's what they're asking you to do. So, let's make the diagram. It's a two-tailed test. Mu 375. The rejection region is on both sides. No, we need to identify the rejection region, which means we need to first get the Z critical and then convert the Z critical to the X critical. So with a significance level of 5%, which means this middle area is 95, 2.5, 2.5, so 0.975. So I think the Z value is 1.96.
Yes.
So Z critical is minus 1.96 and 1.96. Let's convert the 1.96 Z critical to the X critical. So Z equals X minus mu on sigma 1 square root n. So that would be 1.96 equals X critical minus 375 over 15 by square root of 60. So this gives you the X critical as the right hand side X critical. 382.35. So let's take it as 382.4. So if this is 382.4, I don't think we need to recalculate for the other one. Yeah, just subtract, take the difference and go back by 375. So what's the difference? 7.4 ka difference hai, right? So both 7.4 less than 375. What's the other limit? Yes, 375 minus 7.4.
367.
So your rejection region basically is coming out to be, your X bar should be either greater than 382.4 or X bar should be less than 367.6. That's your rejection region. So any sample mean for value that is falling in this region will compel you to reject the null hypothesis and accept the alternative hypothesis. Are you good? Any questions? Given that the actual value of the mean is 380, find the probability of making a type 2 error. So again, the very first thing we need to calculate a type 2 error is the actual value of the null hypothesis, the actual value of the mean. Once you have the actual value of the mean, the next thing that you need is the acceptance region interval. You need to know what is your acceptance region. And then the third thing you need to do is you need to map that acceptance region on the basis of the new mean value. So this is what you're going to do. New mean is 380. Okay. The new mean, the actual mean is 380. And you already know what the acceptance region is. The new mean is right here, 380. And the actual mean and the acceptance region. The acceptance region is x bar in between 367.6 and 382.4. So I guess 367.6 is on the left and 382.4 is on the right. This region is your acceptance region. We need to find the probability of this region, and that would be the probability of making a type 2 error. The probability of the acceptance region based on the new mean value. So how do we find the probability of under a normal distribution curve anyway? We first convert the values to the z value, standard procedure, that's what we're going to do. Let's convert both values to the z value. No, that's based on another, that's z different. We need to recompute the z values here. So recalculate the z values. 382.4 minus 380 upon 15 by 4. Can anybody confirm this? Yeah. 0.64? But exact 0.64? Yeah. Okay. Now what about the left side? 3. Minus 3.306. Minus 3.306. Minus 3.306. Are we sure we're getting this? Guys, please confirm. Yes. Okay. Now, any standard deviation value, any z value that goes beyond 3, we consider that as a value actually lying way inside, right at the edge. The z value, any z value greater than 3 is considered to be right in the corner of the normal distribution curve. So we are not bothered about the area beyond that. It's so much in the corner that any area beyond that is just negligible. So basically it's all this area. From this point till the extreme end. That's what we need to find out. So I'll just refer the table with respect to just 0.64. And whatever the probability comes out, that's the answer. Are you getting the point here? So let's check the table for 0.64. Does anybody have the table? Can you give me the value of the probability for 0.64? Okay. Yeah. 0.64. 0.64. 0.7389. Can you all see that? So 0.7389. This area is 0.7389. And that's basically your probability of making a type 2 error. Is 0.739. Has anybody confirmed these values by the way? Is this confirmed 3 to 2.4?
Yes.
Actually, the probability type 2 is very high, that's why I'm just confirming. Can anybody recompute this? 3 to 2.4, please check.
Yes.
It is? Okay, then the difference is 7.4. 375 minus 7.4, is it this? 367.6?
Yes.
Okay, that is fine. That's fine. That's the probability of type 2. Any questions? Are we good? Can we move on? Let's do the next one. Again, the null and the alternative hypotheses are mentioned. So it's about some random variable, let's say x, which is normally distributed. It's the mean null hypothesis is stated as mu equal to 20, and the alternative hypothesis is mu greater than 20. So we suspect that the mean has increased. So using a sample of 25, now it is decided that the null hypothesis will be rejected if the sample mean is greater than 21.4. What does this indicate? This is the critical region. This is the rejection region. He's already given you the rejection region. He says that you will reject the null hypothesis if the sample mean falls in this range, greater than 21.4. So clearly, the rejection region is x bar greater than 21.4. Your rejection region is already stated. Situation is something like this. You have your null hypothesis being right in center, and the rejection region, it's a one-tailed test towards the right. The critical value is already given to you, 21.4. The x critical. Calculate the probability of making a type 1 error. Do you notice the significance level is not given in the question? So we need to calculate this area. The area of the rejection region is your probability of making a type 1 error, which is also the significance level of the test. So let's convert this to Z critical. So what's the Z critical? So Z critical is 21.4 minus 20 over. What's the standard deviation? Oh, standard deviation is 3.
2.33.
So what is it? 2.33. Okay. So now can we check the table to get the probability for 2.333? 2.0123, 2.3, 1, 3. Add 1 to it. 0.9902. Can you all see that? 0.9902. 2.33 and then 1, 2, 3. Add 1 to it. Okay, so clearly this area is 0.9902. So the one that we require, which is basically the probability of type 1, is going to be 1 minus this.
0.0098.
0.0098. That's your probability of making a type 1 error. There's a less than 1% chance that you will take a type 1 error. Calculate the probability of making a type 2 error. See, again, he's asking for the type 2 error, but he's also giving you the actual mean. The actual mean is 21. So, I think our acceptance region is already defined. Our acceptance region, this was basically part A. So, our acceptance region is basically x bar less than 21.4. Less than or less than equal to it doesn't make a difference. So we're going to base this new acceptance region, base it on new value of mean. The new value of the mean is stated as 21. So your acceptance region is basically from here somewhere. To the left side, it starts at 21.4, right? This is the acceptance region, and the probability of this acceptance region is going to be your probability of type 2 error. So, same procedure, we convert to the z value. 21.4 minus 21 divided by 0 20.
25.
225. 225?
Yeah.
Okay. 0.667. Are we getting 0.667? Okay, let's check the table for 0.667. Let's see what probability provides us. 0.667. 0.667. 1, 2, 3, 4, 5, 6, 7, 23. 0.7477. Right? So clearly this area is 0.7477. So the probability of type 2 is 0.748. Are we good? Any questions? Okay, determine the power of the test. Power of the test is 0.748. 1 minus. It's 1 minus the probability of type 2. 1 minus probability of type 2. Into 100 will be given in percentage form. So that's 25.2%. That's basically the power of the test. problems? Last question of the chapter. Then we're done with errors and hypotheses, in continuous hypothesis. We'll start with discrete hypothesis. Okay. Let's write down the data. Null hypothesis. Null hypothesis mean is the mean breaking strength of the wire is 30 Newton. That's the null hypothesis. But they feel that the mean breaking strength is less than 30 Newton now. So they try to research that is it less than 30 Newton. It's a left tail test. So they are going to research this. They're going to experiment using 9 lengths of the wires, sample size 9. Population standard deviation is given 0.38. Okay, they've already given us the probability of type 1. They've already stated that the probability of type 1 is 0.04, which means the significance level is 4%. This is the area of the rejection region, 0.04, and it's on the left side. So this area is 0.04. Find the set of values in sample mean breaking strength for which it would be accepted that the mean breaking strength is not less than 30. Accepting that the mean breaking strength is not less than 30 means accepting the null hypothesis. When do you accept the null hypothesis? When you fall in the acceptance region, right? Which means this is that region where you're going to fall. So he wants you to state the acceptance region. So for that we need to get the Z critical and then the X critical, right? Z critical aa jayega because I know the probability from here to this end. 0.96. So we look up the table for 0.96 and see what Z it provides us, right? Is it with me? Alright, 0.96. We won't get it right at the end. We'll have to search in the middle somewhere. 0.96. Closest to 0.96 that I think we can get is this. That's 1.701235. 1.75? Add 1 and that's the first position to 1.751. 1.751 is the Z value. Is everyone okay with that? The Z value over here is 1.751? Negative 1.751. Please don't forget to put the minus sign, the values on the left. Your answer will come out wrong when you convert it to the X critical. Okay, so minus 1.751 equals X critical minus 30 upon 0.38 divided by root of 9. So this should be your X critical as 29.7. So 29.8. Let's take it as 29.8. Are we all getting this? So your acceptance region is x bar greater than 29.8. This is the range of values of the sample mean breaking strength that would compel you to accept the null hypothesis, that is, that the mean is not reduced. Is everyone okay with this? At the back, are we good?
Yeah.
Now, given that the probability of making, now he is giving you the probability of making a type 2 error. Now, the probability of making a type 2 error is to be less than 0.025. Find the set of possible values of the actual mean breaking strength. So, okay. Is everyone okay with this? Can I rub this and make the diagram here? Okay. So, how do we calculate the type 2 error in the first place? We identify the acceptance region on the basis of the new mean value. This time I do not know what the new mean value is. I don't know what the new mean value is. But I know that the probability of making a type 2 error is less than 0.025. Now I know that my acceptance region is towards the right. That I already know. And do you see the probability? Is it more than 0.5 or less than 0.5? Yes. Then, and you know the acceptance region is towards the right. So where do you think is your area something like this?
So left
See, wait. The acceptance region is starting from a value towards the right side. Right? It's going towards the right. Okay, now that area, this region, x bar greater than 29.8, this region on the basis of the new mean value, the probability of that acceptance region is only 0.025. So would it be a tail area or a body area? First one is going to be a tail area. So would it be a left tail or a right tail? Was your acceptance region towards the left or was it towards the right? So it's a right tail area. It's a right tail area. This value over here is 29.8. So definitely your mean value is less than 29.8. But we need to find out the range of the mean value. He's saying that this area is not exactly 0.025. It's less than 0.025. This is what they're saying. So if this area is less than 0.025, then can I say, to be more precise, can I say that this value right here, x critical value, this x value over here is greater than 29.8? Because if I keep the value exactly 29.8, this area is 0.025. If I'm going to make this area smaller, will this value not shift more towards the right? Which means that actually this value is more than 29.8. Are we okay till here? Is everyone okay till here? Okay, now this value is more than 29.8. Can you calculate the actual mean? Now, how do you go about calculating the actual mean? You say z critical, z value here is x minus mu upon sigma upon square root of n. So your x value here has to be mu plus z sigma upon square root of n. Check. Will this come out or not if I make x the subject? Will you get this or not? If I make x the subject, this is what we're going to get, right? Now they are telling me that the x value, now we figured out, because the area is less than 0.025, so this x value over here has to be greater than 29.8. So if this x value is greater than 29.8, which means this is greater than 29.8. Therefore, I can say mu plus z into sigma upon square root of n is greater than 29.8. Let's get the value mu out. So this implies mu is greater than 29.8 minus, what's the z value by the way? Acha, ab z value will be computed on the basis of, so what is the point 0.975. So what's the z value for 0.975? 1.96. What was the z value? 1.96. Yeah, 1.96 times, what's the sigma value?
0.38.
What was it?
0.38.
0.38, yeah. 0.38 over square root of
9.
square root. Check. So mu should be greater than okay, I think I got the inequality wrong. Wait. Guys, wait. Sorry, I made a mistake. Let me just go back. I made a mistake. Let me just go back. Values are correct. 1.96 of 3 I made an error here. I should have not taken the x bar. I should have taken the z value. Z value is how much? Okay, now if this area is going to be smaller than 0.025, your z value is going to be greater than. Your z value is going to be greater than 0.96. This is what you need to take. Sorry, I took the x value, I should have taken the z value. Your z value should be greater than 1.96. Because z ko to बाद में convert करेंगे to the x, right? First it's the z value on the basis of which you have your area. So if this area is going to be smaller than 0.025, your z value is going to be larger than 1.96. Because at 1.96 your area is 0.025. So considering that as z is this, it means x minus mu upon sigma upon square root of n should be greater than 1.96. Now calculate. सिर्फ गलती आ रही कि mu का जो हम पहले कैलकुलेट कर रहे थे उसका greater than आ रहा है, इस दफा less than आ रहा है. So mu is less than. Value same आती है मगर inequality का sign अलग आ रहा है. This is the right way of doing it. So let's make mu the subject. So I think if you make mu the subject, your mu is going to be less than x minus 1.96 times sigma square. Check ये आ रहा है? नहीं, value different. You made a blunder. It's fine. So can you calculate this? X is how much? 29.8, 1.96, 0.38 over square root of 9. Check. What is that? 29.55. Okay, so 29.6. So your mu should be less than 29.6.